Sorry, I sometimes forget. Right, so if you sum this up, you will get the population mean to be equal to 6. All right, that's part one. Part two is to find the population variance. So sigma squared, which is the variance of x1. Now you may recall from probability 1 that you took last semester that this can be written as this. Now this guy we already know is 6, so 6 squared is 36. So we just need to find this guy here, right? So this gonna be 2 squared times 1 over 5. Right, and minus 6 squared is 36. Right, now if you do the math for this, you will get this to be 10.8. So the variance is 10.8 and the population mean is 6. All right, guys, are you okay so far? If you have questions, feel free to use the chat room, guys. Okay. All right, now the third part, the part 3 of question 3 is asking, by considering all possible samples, compute the mean and the variance of the sampling distribution of x bar, right? All right, now to do this, the first thing you need to do is this. This is question 3, part 3, right? The first thing you need to do is to list the possible outcomes for x1. x1 is the first number that you're choosing. x2 is the second number that you're choosing, and the corresponding values for x bar, right? All right, now let me show you how to do this. Because there are 5 numbers, there are 25 possible outcomes for x1 and x2, right? So the first possible outcomes will be 2, 2. Next, 2, 3, 2, 6, 2, 8, 2, 11. The next one will be 3, 2, 3, 3. Because you're sampling with replacement, so 3, 3 is possible, and so is 2, 2. 3, 6, 3, 8, 3, 11. Okay, all these are possible numbers. Then you can have 6, 6, 2, 6, 3, 6, 6, 6, 8, 6, 11, right? And then you can have 8, 8, 2, 8, 3, 8, 6, 8, 8, 8, 11. And finally, you can have 11, 2, 11, 3, 11, 6, 11, 8, and 11, 11. All right, so these are all possible these are the 25 possible outcomes that you can have. Right, for each of these outcomes, there's a corresponding value for x bar. So for 2, 2, x bar is the average, which is 2. For 2, 3, the average is 2.5, 4, 5, 6.5, 2.5, 3, 4.5, 5.5, 7, 4, 4.5, 6, 7, 8.5, 5, 5.5, 7, 8. Correct me if I'm making a mistake. 9.5, 6.5, 7, 8.5, 9.5, and finally 11. All right, you see what I've done? I have created a table. The first column gives the possible outcomes, and the second column gives the values for x bar, right? All right, now the next thing I'm going to do is to create a table for the probabilities. Right, now to do that, I'm going to create a table of different values for X bar and the corresponding probabilities. Right, you see these are the values that we got for X bar, but some of these are repeated. So for example, 2.5, you have 2.5 here, and you also have 2.5 here. So some of these values are repeated. So we need to work out the distinct possible values for X bar, which are 2, 2.5, 3, 4, 4.5, 5, 5.5, 6, 6.5, 7, 8, 8.5, 9.5, and 11. So these are the different possible values for X bar. And the corresponding probabilities. For 2, you only have one outcome with. So you should look at this table one more time. You only have 1, 2. So it's 1 out of 25. For 2.5, you have 2 outcomes. The 2 outcomes are this one, 2, 3, and 3, 2. Both of them give you 2.5. And for 3, you have 1 outcome. For 4, you have 2 outcomes. Next one is also 2. And for 6, you have 1 outcome. 6.5, you have 2 outcomes. Right, so you see, this is the probability table for giving the different possible values for X bar and the corresponding probabilities. Now, using this table, we can work out the expectation and the mean of X bar. So the expectation of X bar will be just this multiplied by this and sum, right? Right, so if you sum these guys, you will get 6. And the variance of X bar, to find the variance, I'm going to use this formula one more time. Okay, this guy we know is 6, so we just need to work out this guy here, right? To work out this guy, I'm going to use the table one more time. So this is going to be 2 squared times 1 over 25 up to 11 squared times 1 over 25, right? Minus 6 squared, which is 36, right? Okay, now if you do the math for this, you will get this to be 5.4. All right, guys, so this completes question 3. Are you okay with this or no? I mean, feel free to talk to me, guys. If it's not okay, I'm prepared to go over again. Okay, thank you, guys. All right, so that completes question 3. Now, the next question is question 4. Question 4, remember in question 3, we did everything with replacement. Now in question 4, the only difference is that we're gonna do the same thing, but without replacement, all right? Okay, so let's see how we can do this. So question 4. So once again, we need to create the 2 tables. The first table, right, this is the first table. And the second table is X bar, right? Right, the possible outcomes for X1 and X2. X1 is the first number that you choose, X2 is the second number that you choose. So it's gonna be 2, 3, 2, 6, 2, 8, 211, 36, 38, 311, 68, 611, and 811. Now you may think that why I haven't put, I mean I have put 2 3 but not 3 2. I put 2 6 but not 6 2. That's because the order does not matter here. Order does not matter in this case. So even if you put 2 3 and 3 2 and 2 6 and 6 2 and so on, the answer that you will get in the next table will be the same. I will explain that later in a more clearly. Okay. Now the sample mean corresponding to 2 3 is 2.5. For 2 6 is 4. For the next one is 5, 6.5, 4.5, 5.5, 7, 7, 8.5, and 9.5. All right. All right. Now I'm going to create the probability table. So 2 columns one more time. And in this column, I'm going to list the values for X bar, the different values for X bar, which are 2.5, 4, 4.5, 5, 5.5, 6.5, 7, 8.5, and 9.5. Right. So these are the different values for X bar. And the corresponding probabilities are 1 over 10, for 7, there are 2 outcomes with 7. This one gives 7, this one also gives 7. So there's 2 out of 10, right? And okay, so this is the probability table. Now let me go back to what I meant. When I said order does not matter, what I actually meant is this, that this table here, the probability table here will not change. This table will be the same even if you include the different orderings like 3 2, 6 2, 8 2, all those. If you include all those orderings, the table that you get here will be precisely the same. It will not change, right? That's what I meant when I said order does not matter, right? Okay. All right. The next thing I'm going to do is to compute the expectation and the variance, right? Okay. So this is the probability table. I'm going to use this table to compute the expectation of X bar and the variance of X bar. So to compute this, I just multiply this with this, right? So it's going to be 2.5 times this up to 9.5 times this. Now, if you do the math for this, you will get this to be 6, right? Next, the variance. To find the variance of X bar, you use this formula. All right, which is what I used earlier several times. All right. To find this, I'm going to use the table one more time. So it's going to be right, and take away 36. Now, if you do the math for this, you will get 4.05. Okay. So you see what's happening. Do you see what is happening here? That in the let me show you what is happening here. These, you may recall just a few minutes ago, these are the numbers that we got. These are the numbers that we got when it's with replacement. okay, when it's with replacement. And these are the numbers that we are getting now. These are the numbers that we are getting now without replacement. Okay, so you see that how they compare. The mean is the same. The mean is 6, and the mean is 6 here too. But the variance here is 5.4, and the variance here is 4.05. So this one is better. Remember, the smaller the variance, the better the estimator. So the one without replacement gives a smaller variance. So the conclusion is the following: that the means are the same. The means are the same, right? But the variance is smaller for without replacement. So in this case, without replacement is better than with replacement, right? Okay, guys, is that clear, guys, or not? Just please feel free to talk to me, guys. Don't be shy. Okay. All right. Thank you, guys. All right. Now let's go to the next question, which is question 5. So this is question 5 is this one, right? You have a population with 5 different numbers. The first part is to calculate the population mean. So let's see how we can do this. So question 5, part 1, right? So you have your population with these numbers 3, 7, 9, 11, and 15. So and you're picking just one number, right? You're just picking one number out of the population. So the outcome can be 3, 7, 9, 11, or 15. And the probabilities are 1 over 5, 1 over 5, 1 over 5, and 1 over 5. Okay. So the population mean is just simply the mean of the random variable, which is this multiplied by this, right? And so you get 3 times 1 over 5 up to 15 times 1 over 5. And if you do the math for this, you will get this to be equal to 9. Okay. All right, guys. So that's part 1. Part 2 is to write down all possible samples when you do it without replacement. But here you're picking 3 numbers, not 2. And then find the mean and the variance of X bar. Right. So this is part 2 of question 5. So the first thing you need to do is to create a table with these columns, right? So the first column is gonna give you the numbers that you choose. You're choosing 3, not 2. So the first possible outcome is 379. Remember, we are doing it without replacement. Okay. 7, 9, 11, 7, 9, 15, 7, 11, 15, and finally 9, 11, 15, right? So these are the different outcomes, right? And the corresponding values for X bar is the average, is 19 by 3, 21 by 3, 25 by 3, 23 by 3, 27 by 3, 29 by 3, 27 by 3, 31 by 3, 33 by 3, and 35 by 3. All right. All right. Now, once again, the order does not matter because the order, once again, does not matter. The reason for that is the same as what I explained before. The probability table that you will get will be the same even if you include the orders. Like if you include 379 and 397 and 937 and all the possible orderings, you will get the same probability table, which I'm going to do now. So this is the probability table. This is the column that gives the different values for X bar. All right, okay. And did I do this right? Just a minute. Yeah, okay. And the corresponding probabilities are these. There are two outcomes with 27 by 3, I think. Okay, so this is what you get. All right, so this is the probability table. And as I said, this probability table it will be the same even if you include the other possible orderings, right? Okay. All right. So, okay. Now let's find the expectation and the variance. So the expectation is gonna be this multiplied by this, and then take the sum. So it's gonna be this, right? And if you take the sum, this will be 9. Now to find the variance, I will use this formula, which I have used several times already, right? This one I know is 9. 9 squared is 81. To find this one, I will use the table. So this is going to be 19 by 3 squared times 1 over 10 up to all the way up to 35 by 3 squared times 1 over 10 minus 8 squared, which is 81. So 9 squared, which is 81, right? Now, if you do the math, this will turn out to be this. All right. Are you okay with me, guys, so far? Right. Okay. Now, the next part of question 5 is this. Now, it's saying instead of computing the sample mean, which is X bar, compute the sample median. So I'm going to compute the sample median in place of the sample mean. Right, so I need to do the tables one more time. So the first table, so this is question 5, part 3. The first table I need to do is the outcome table and the possible values for the median. Right, the outcomes are 3, 7, 9, 3, 7, 11, 3, 7, 15. right? So these are the outcomes. There are 10 outcomes, I think 3, 6, yeah, 10 outcomes. And the corresponding, remember the median is the middle number when you arrange the data from the smallest to the largest. So the median for this is 7. The median for this is also 7, 7, 9, 9, 11, 9, 9, 11, and 11. All right, so these are that's the outcome table. The next table I need to do are the different values for median and the corresponding probabilities. Now there are only 3 different values for median, 7, 9, or 11. Right, and the corresponding probabilities are 7 occurs 3 times, so it's 3 over 10, 9 occurs 4 times. All right, so this is the probability table. All right, now let's find the expectation and the variance. To find the expectation, you just multiply this with this and sum. So it's 7 times 3 over 10 all the way up to 11 times 3 over 10. Right, so if you do the math for this, you will get this to be 9. Right, and to find the variance, of the sample median, use the formula I used several times already, which is all right. We know that this guy is 9, so we just need to compute this guy, right? To compute this, I'm going to use this table here one more time. So it's going to be 7 squared times 3 over 10 all the way up to 11 squared times 3 over 10 minus the square of the expectation, which is 81. Now, if you compute this, this will be 2.4. All right, now the final part of question 5 is to compare. All right, let me put this in a box so you can see what I'm trying to do. So these are the expectation and the variance when we deal with the sample median, right? So it's 9 for the expectation and 2.4 for the variance. Now, if you go back to what we did previously, you should go back to what we did over here. This is what we got. This is what we got for the sample mean. When we deal with sample mean, this is the expectation and this is the variance that we got, right? And when we deal with the sample median, when we deal with the sample median, we are getting the expectation to be 9 and the variance to be 2.4. So you see the difference. The difference is that the means are equal. The expectations are equal. Both are equal to 9, right? But the variance is smaller. The variance is smaller for the sample median because the variance for the sample mean is 2.667 and the variance for the sample median is 2.4, right? So what you need to write down is the following. For the final part of question 5, this is what you will write down. You will write down the means are the same. The means are the same, right? But the variance is smaller for the sample median. Okay, the variance is smaller for the sample median. All right, guys, you get this or not? Hello, guys, talk to me. Okay, now let's go to question. The next question is question 6. So we just have 2 questions left. Question 6, which is if you have a random sample of size 10 from the uniform distribution on the interval 0, 1, find the mean and the variance of x bar. I'm sure you know how to do that, right, or not? I know I'm running out of time now, but so you have I mean, you guys know this notation, right, or don't you? This notation means uniform variable on the interval 0 to 1, right? Okay, so now to find the expectation, you do this and take the expectation inside. Right, this is what, now I'm sure you know from probability 1 that the expectation, I mean, okay, let me write it down. You probably remember this from last semester, that if you have a uniform random variable from A to B, then the expectation of X is A plus B divided by 2. Do you remember this or not? Guys, do you remember this formula or not? Right, okay, so using this formula, you get 1 over 10 times the sum 1 to 10 of A is 0, B is 1, so it's a half, right? Okay, so this is 1 over 10 times 10 times a half, which is equal to half. All right, so that's the first part. The second part is to find the variance of x bar. Okay, now you take the variance inside. So when you take the variance inside, you need to square the constant. So this becomes 100 times the sum, 1 over 100 times the sum of the variance of xi. Right, now, once again, you may recall from probability 1 that if you have a uniform random variable from A to B, then the variance of that variable is B minus A squared divided by 12. All right. Do you guys remember this or not? You probably remember this anyway. Okay, so your B is 1 here, A is 0. So if you put that, you get 1 over 100. It will be 1 over 12, right? Okay, with B equal to 1 and A equal to 0. So this will simplify to, excuse me, to this, and this will become this. All right, guys, so this completes question 6. Question 6 is easy. I don't think I have the time to do question 7, but I will post the full solutions later today. So you should go to the course website. I'm sure all of you know where the course website is, not in Blackboard, all right? You will see the full solutions to all 7 questions later today. It will include typed solutions and handwritten solutions, and also a video solution for all 7 questions. So all 7 questions in the tutorial sheet. Number 2. All right, guys. And by the way, I will send you your mark and your feedback in the next hour. So check your email. In the next hour, you will get an email from me giving your mark and the feedback for quiz 1. All right. So have a good day, guys. I will talk to you. I'll talk to you later. Okay. Have a great day, guys.